Hello everyone. So in this video we will be talking about the directory structure of operating system. So there are different four types of directory structures which operating system typically offers. The one which we typically use or nowadays we use, it's called acyclic structure. So let's talk about directory structure, why directory structure is important and why do we use an operating system. So directories basically are used in order to optimize, the file search, in order to optimize, create a file, in order to organize the data. If you want to organize the data and if you have not directories, the data will be very highly disorganized. By using directory structure, we can optimally search a file, we can create a file, we can easily delete a file, we can easily, for example, write onto the file, rename a file or rename a directory, or we can also traverse a file system. So all these are basically features which came after the directory structure came in. One of the example of the directory structure is single level. In single level, it's very simple. That's like as name suggests. For example, I'm talking about a server base. Let's say we have a root directory. Let's say A. This is our root directory. All right. And all the users or all the other applications, they basically use or they put the files under root directory. So for example, we have a file 1, F1, F2, F3, three files, or belong to a specific user or created by a specific user. So all the files will be located under root directory. So all users or the files or the programs files will be located under main directory, root directory, under root directory. All right. Now, what would be the problem? It's very easy. Like you created a file, put the file under it. All the record for a specific file. Let's say F1 has R1, R2, R3. F2 has R1, R2, R3. Similarly to this, everything is co-located under one directory. Biggest problem it will generate. It's easy to implement, but biggest problem is the naming problem. What is the naming problem? Naming problem means if F1 has a file or a record, let's say abc.txt, all right, the file F1 created by a specific user or app. Similarly, F2 cannot have abc.txt. It's going to be a problem, naming problem, overlapping. Second problem is grouping problem. Grouping problem means, let's say F1 has, or for example, if I take F1 as a user one, for example, user one has a file, let's say Java based file, doc, Microsoft Word based file, or for example, let's say C++ based file. All these files, having said that, they are created by or required for different type of application, but they would be co-located under the file systems, right, under the one directory. So you don't have a specific groups for, let's say all Java file would be under this, all for example doc file would be under this. So all the files are co-located. That's the biggest problem. In order to resolve this issue, the second level of file system came in, which is called two level, where we have a root directory. And then for every user, we have created the user directories. So this is basically root directory. Under root, we have the user directories. All right. Let's say B, C, D. And every user can then further create F1, F2, F3 and all that. The naming problem has been resolved. Somehow the naming problem has been resolved. Let's say if you take it like a file based or program based. So every program, they can have different name of files. Naming problem has somehow solved, but the grouping problem was still there. Let's say if this is user one has created a file, Java based file, doc based file, still all the files will be co-located. All right. To resolve this issue, another structure came in, which is called tree based structure. Root directory. This is root directory. Under the root directory, let's say we have user directories, or you can say file directories. User directory B, C, D. Under user directory, user can create further different types of directories. Let's say this is program 1 having different file, program 2 can have file, etc., etc. The best thing about it, naming problem has been resolved. No overlapping, all right, between different user application or between different file system. No, the grouping problem have been resolved, but still there is a problem. Let's say if user P1, program 1, wants to communicate or access the data of directory D, like say this program, let's say, which is P7, owned by this one, they cannot communicate. In order to resolve this problem, the one which we currently use, it's called acyclic structure, which allows different inter-directory communication, allows inter-directory communication. That's the one which we use today. Acyclic structure. Thank you very much.